Good afternoon, students. Today, our topic of discussion is virtualization, continuation. Just go through all the concepts which we discussed. Next topic is emulation. Emulation means imitating others. Emulate means imitate. So here, imitating others in the sense that other system or other machine. There is a one kind of machine, a system imitate to be another system. That is known as emulation. Can you give me an example of emulation wherein a system imitate other system? You know it. You know that example. Okay. Have you heard about a virtual box in a Windows system? You have a Windows system. In the Windows system, if you have to run anything related to Linux, so you can install a virtual box. In this virtual box, you can install an interface of Linux and then you can execute. Although your machine is Windows machine, it is behaving like a Linux machine when it is in this virtual. And also some of the applications which you cannot directly install in your operating system due to compatibility problem or any other you know issue, what you can do is you can put on a virtual box and then you can execute your program in that virtual box. This is also, suppose this is Windows, and then you are emulating the behavior of Linux through VirtualBox on Windows. This is emulation. And emulation software converts binary data written for execution on one machine to an equivalent binary form suitable to execute on another machine. What does this means? This means that um, you are executing, this is machine A, machine A, machine B. This is system A, this is system B. You are executing a program in A, executing a program. What you do, you execute the program such that the executable file can be executed on this B. Here the output.
Ma'am, good afternoon, ma'am. Rakesh here.
Yes, Rakesh. Any problem?
No, ma'am.
Okay. Are you all able to hear me? Everything is
Yes,
okay?
sir, I can. Yeah, ma'am. I'm
Okay.
unable.
Okay, Rakesh. So you are executing a program and the executable file, which is the output of this executable file, is in a format that can be executed on another machine. So you put your executable file on this and then you get the output of the program. This is known as emulation. Although the system is A, in it has its own format, it is producing a executable file that can be executed on another machine. So it is like emulating. And then uh, The principle of emulation in computing is instruction set translation through interpretation. Here, this machine might have another instruction set, this machine might have another. However, because you have a emulation feature enabled, this is generating an output executable file that can be directly executed by the system B, which understands this instruction format. Because this executable file has an instruction format, uh, I don't know why this feature is not working. Okay, but anyway, all of you, please mute yourself. So this is emulation.
Rakesh.
Next,
Yes, Sagar. Sagar.
Rakesh,
Hello.
please mute your
Yes.
mic.
Yeah.
All right. Next, uh, what is simple? Can anyone give me the difference between simple virtualization and emulation based virtualization? There is a concept called virtualization. We have been studying it all through this week, and today we understood what is emulation. So, what is the difference between simulation, simple virtualization, and emulation based virtualization? The difference is that in simple virtualization, the output A generates the executable file for itself. Means when you execute a program execution, output is executable file for A only. This is simple virtualization. Emulation based virtualization. In emulation based virtualization, you have um, a system A generating the output in the form of executable file to be executed on another machine. This program output executable file is for B. This is emulation virtualization. This simple virtualization. Okay. Next, some other types of virtualization. Can anyone respond in the chat window what types of virtualizations we had studied? We had studied machine or server virtualization, and we had studied different types of virtualization like para, uh, full, and hardware assisted. This comes under uh, hypervisor based virtualization. Hypervisor based, these machine virtualization techniques are of two kinds: host OS based virtualization and bare metal virtualization. Bare metal virtualization is uh, hypervisor based. Then hypervisor we have three kinds: full, para, hardware assisted. This we already covered. Next are some other types of virtualizations. Other kinds of virtualizations are other virtualizations. First one is network virtualization. Then you have storage virtualization. Then you have desktop virtualization. Let us look at network virtualization. What is network virtualization? It is the process of combining network resources and network functionality into a single software-based administrative entity called as a virtual network. Network virtualization is combining network resources and network functionality. What are the network resources and functionality? It is all about connecting from one device to another device. It is about network virtualization. So in network virtualization, um, I'm writing in short, virtualization. V. Network virtualization means it is combining network resources with network functionality. And these two in single entity called as virtual network. Okay, you combine network resources and network functionality into a single unit known as virtual network. There are two forms of virtual network. First one is virtual device based virtual network. Virtual device based virtual network. And second one is protocol based virtual network. Second one is protocol based virtual network. What is virtual device based virtual network? In this, virtualized devices form the network. Virtualized devices form the network means what? To connect to network, you have a network card, Ethernet card. If the card is not located in your system, if it is located on some other system and you are connecting virtually through it, for instance, you can use mobile hotspot. So your mobile will function as your internet device through which you can connect to your system. Here you have computer system. This is mobile. Through mobile, in mobile, you have internet connection, and through mobile, you are getting internet connection to your computer system. So this is known as uh, virtual. It's sort of virtual. Virtually, uh, internet is not physically there in your system, but through mobile you are getting it. So that is virtual device based virtual network. And protocol based virtual network is, it will create a virtual area network. Instead of virtualizing the devices, here we are virtualizing the device. Instead of device, for this, what you do is protocol based means it creates a virtual area network, also known as VLAN, virtual local area network, virtual LAN or VLAN. And VPN. What is VPN? Virtual private network. You may not have a private network. Um, I think you know about VPN. If you have taken any service of VPN, so what it does is on the internet, which is a public network. This is the internet. This is a public network. This is your device. This is the destination device. Whatever you send out on the internet, this will go through several devices and reaches the destination. This is source. This is your system. This is your mobile. This is source and destination. Here, anyone can view your information which you have sent out on the internet. What you can do? What is the other way? Other way is to create a virtual private network. You create a network in which you have, this is, consider this to be a network, this channel, this pipeline what I have drawn, this is actually a private network which is created on a public network. It is not physically a private network. You have not laid down the cables and do necessary uh, operations in order to create a private network. How are you creating a private network? You are creating a private network on top of public network, so it is termed as virtual private network. And if there is a LAN, and if you are creating a LAN from that another LAN, then it is known as a virtual local area network. These are networking virtualization. Storage virtualization, as you know, the second one is storage virtualization. If you are not storing on your machine and um, means the storage is, suppose if you have a mobile device and you have a memory card. This memory card is associated to this mobile device, your smartphone. Means this you fix inside this. That is physical storage. Another way is you have a mobile device, you have a storage somewhere else. This storage is not physically tied to your mobile. It's not associated here. It is somewhere else, but you are able to store. Here, this mobile device will get inside this like this. This memory card. These memory cards fit inside mobile device. I mean, this is physical storage. This is virtual storage. This is about storage virtualization. Desktop virtualization. Desktop, all of you know desktop. Now I am using my laptop, a personal computer, or I can have a desktop means a computer system with a monitor, cabinet, keyboard, mouse, and all. That is a desktop. Desktop virtualization. You don't have physical desktop with you like this. Physical desktop you don't have. You are accessing the desktop through mobile, for instance. Desktop is somewhere else, and you are performing all the tasks that you can do on a desktop. Physically, desktop is not available, but logically, virtually, it is available. So this is desktop. Desktop. This may be mobile device. This is desktop virtualization. These are the other types of virtualization. So again, let us quickly uh, look at what we have studied through the concept of mind map. We have started with the concept of virtualization, and then we defined what is virtualization. Virtualization is about um, the resources are not in physical form, rather they are in simulated form. That is virtualization. This is virtual class. What is happening? How is it virtual? Physically, we are not there in a single room where I am using chalkboard and you are using your notebook pen and I'm writing and then you are taking down. That's not happening. Still, the essence of class is preserved here through virtualization. So physically, it is not happening, but virtually it is happening. That is virtualization. It refers to representation of physical computing resources in simulated form. In this virtualization, first we saw that um, how you can perform this physical computing resource virtualization. Physical resource virtualization we saw, and then we saw the business benefits, how in business this physical virtualization is helpful, and then we saw the machine or server level virtualization, machine or server virtualization. And then what we saw that in this we have two forms: hosted approach and bare metal approach. This is hosted approach and bare metal approach. In hosted approach, you have operating system after uh, physical computing resources. Here you don't have operating system on physical resources, rather you have hypervisor. And here you hypervisor is also called as hypervisor or virtual machine monitor. And then okay, I want to expand this here. So how should I do? Okay, here I am using in this manner. This hypervisor or virtual machine monitor is divided into three approaches, three ways in which you can arrange. First one is full virtualization, and then you have para virtualization, and then you have hardware assisted virtualization. This is with respect to bare metal, hypervisor, or virtual machine monitor. Then we studied about operating system or OS level virtualization. OS virtualization. So I'm not writing virtualization because virtualization is already here written here. So it is OS level virtualization. And then we have studied about major server virtualization products and vendors. Um, server virtualization means this machine or server. Means I will write machine or server virtualization products and vendors. We have studied about VMware, Citrix, Zen Server, Microsoft Hyper-V Server, um, Oracle, VM Virtual Box, and KVM. Then we looked at High level language virtual machine. High level language virtual machine. And then today we understood what is the meaning of emulation and also other types of virtualization. Other types. In other types, we have uh, three. What are they? Network, storage, desktop. Okay. Next topic is now we will study advantages of virtualization, downsides, threats, and recommendations. So here we have advantages, downsides means disadvantages or limitations, and threats and recommendations of virtualization. Then this is known as a mind map, which gives the overall idea about the chapter on virtualization. Let us look at advantages. Advantages of virtualization. So the first one is better utilization of existing resources. Better utilization of existing resources. How you can better utilize existing resources? If the resources, physical resources, if they are not in use, what you can do? You can connect it to multiple um, users. If suppose you have a very high end machine, this high end machine can be connected to user 1, user 2, user 3, user 4. If it is connected only to a single user, what happens is if this user is not accessing this, the resources are not used. And if you give the access to multiple users through virtualization, then probably this user might be using, this user might not be using, this user is also using, this user is also using. So what is happening is it is better utilization of resources. Then you have reduction in um, hardware cost. First one is better utilization. Second one is reduction in hardware costs. Because here again you can look at this one server is serving to multiple users. So each of them do not have to buy their own machine. So it is kind of economical, reducing the hardware costs. Third one is reduction in computing infrastructure costs. Again, it boils down to the same idea. Reduction when you are using it mm, in a shared mode, then you are reducing the costs dramatically. Reduction in computing infrastructure cost. Computing infrastructure, whatever you require, if you have to purchase a new machine for your own work, your own personal computer, then you have to have other infrastructure, computing and a heating, lighting, cooling, not heating, cooling and lighting. So all that, everything you have to bear. But if you use it through virtualization, you are reducing. Improved fault tolerance. How it is? How are you improving fault tolerance? Because If one server goes down, you can use another server, and then um, fault tolerance means if there is a failure, if system A fails, system B immediately takes up. This fails and this takes up. So that failure is not probably known to you, or might have been hidden from you, might be transparent. Simplified system administration. How the system administration is simplified? Simplified system administration. It is simplified because, yeah, you have one admin maintaining the server, and there are so many users accessing the server. This maintenance is the responsibility of this one admin and this service provider. They all are not concerned about this. They all just use. They don't maintain. Maintenance lies on this. Okay, next, simplified capacity expansion. Simplified capacity expansion because, what do you mean by capacity? If a machine is having 8 GB, if this is having, consider 8 GB RAM, you can expand this machine to a 16 GB RAM, and it's very simple. At one place you have to do it, all the users access it. All the users need not have to do it. And simplified system installation, everything related to maintenance, installation, updation, expansion, everything is simplified. Simplified system installation because at one place you are doing it, you're not doing it at multiple places. Then support for legacy systems and application. Through virtualization, you can get the support for legacy systems. What do you mean by legacy systems and applications? If suppose there are certain old um, applications on this machine, you have one old. What happens um, is suppose you take railway reservation system. Railway reservation system has been updated, um, perhaps 1 2 years ago. Before that, it was having some interface, and when it has started with first application, it was different. So that can be termed as old or legacy system, and this will be updated to new, and again this new will be updated to another new. So this preceding systems are known as old systems, and very old will be known as a legacy system. Because you have a through virtualization, there is a layer of virtualization here, so anyone can access these old systems as well. If you place them at one machine, and through virtualization you can access. And you have simplified system level development. This is ninth. Simplified system level development. So what happens here is you are developing device drivers, um, and other applications, that all is developed only for one machine, because physically it is one. This is a physical machine. But through a layer of virtualization, the multiple users are accessing. This is all virtualization. Here you have virtual user 1, user 2, user 3. So what this user 1 can do, can easily develop on this. User 1, user 2, all of them are developing for one single system, and developing of the system on uh, virtualization is quite easy, because you are doing it in virtual environment and it is faster and easier. And simplified system and application testing, after you develop it, you have to um, test at system level and also at application level. Physically, if you have a machine, it might take time, because you have to do necessary setup and other related tasks. Because here through virtualization you are doing, all the testing also becomes simplified. And security is mm, provided only at one physical resource. And because virtualization adds a layer of abstraction over the physical hardware, and virtual machines cannot directly access your physical resources, so there is a security. Here you have hardware resources, on top of it you have virtualization hypervisor. So all the users, user 1, user 2, user 3, they are accessing these hardware resources through a hypervisor or virtual layer. They are not accessing directly. So there is a security preserved, and our physical devices remains unaffected, and users cannot directly interact with this hardware. This is hardware. This is virtual. These are the advantages of virtualization. And the downsides are very few. Downsides of virtualization: first one is single point of failure problem. If there is no backup, essentially failure of the physical machine implies failure of all the users connected to it if there is no backup. And lower performance issue: when the system's configuration is not that high and several users get connected, then users might face the problem of performance, because one machine is serving to so many other users. And difficulty in root cause analysis: if there is a problem, uh, by being distant, away from the physical resources, it becomes difficult for a user to analyze the cause of the any problem that is happening. Difficulty in root cause analysis. Okay, these are the downsides of virtualization. And then threats. What are the threats? You also have virtualization security threats. Virtualization security threats. So the first one is a single point host. Because resources are being shared, it is cost effective, and a single physical resource can fulfill multiple users requests. And any security breach, any hacker, if he obtains the access to that physical resource, then the entire system breaks down. And Many users will suffer because of that. So the single point host is a threat. Second one is threat to hypervisor. Hypervisor is the layer of virtualization. If any malicious user gains access to this, even then it is very difficult to protect the system. And complex configuration. Why it is complex configuration? Because virtualization adds another layer. Here your machine has physical resources. On top of it, it has virtualization, virtual layer. This virtual layer is a complex software. So because of that, it adds complexity to the system. Privilege escalation. Privilege escalation is an attack, that happens when users or some other applications get access to more resources or functionalities than they are entitled. What happens is a user, this is a through virtualization, user one gains access to the, actually user one can access only the hypervisor, but for some uh, at some particular point user gains access to hardware as well. Then this is like escalation, means the access point has raised, then user can do anything. Because of that also there is a problem. Inactive virtual machines. When virtual machines are not active or in dormant state, what happens is they generally moves into a monitoring system. But then there may be some sensitive data stored. Here what I mean is, you have a virtual machine. In this, user's sensitive data is stored, and then it has stopped functioning. Because it has stopped functioning, it has moved to inactive state where users cannot access it. But users' sensitive confidential data remains stored in this. So that is also one of the security threats of virtualization. And consolidation of different trust zones. Consolidation of different trust zones. This means that there are different trust levels. You have different permissions. You have read permission, you have write permission, you have execute permission. Likewise, you have different zones, trust zones. Means an admin will have more privileges, users will have less privileges. But then if this separation is not maintained, and if these trust zones are being hijacked, bypassed, if users are able to do whatever an admin can do, then what happens is um, a problem arises, security problem. So this is about the virtualization security threats. Next, the last virtualization security recommendations. Next topic is virtualization security recommendations. So in this, what we are going to study is, um, we are studying about hardening of first virtual machine. Means users have indirect access to computing resources. So applications run on top of virtualization. So you have to harden means users should access virtual machine through virtualization. So hardening of virtual machines, hardening of hypervisor, hardening of host operating system. You have to harden means make them strong and protect them so that no user can gain um, illegal or malicious access. And the hardening of all this you have to do, plus you have to, this is one, one, two, three, and fourth one is restrictive physical access to the host. We have to restrict physical access means no one should, in bank when you go, there will be locker room. Everyone will not be allowed inside that. So there will be physical access, restricted physical access. So host should not be given access in physical mode. And you should have an implementation of single primary function. You have to implement of single primary function per virtual machine. So you have to implement each virtual machine should do one primary function. Actually, virtual machines are capable of handling multiple tasks. But to make them more secure, you have to have single primary function. And you should use secure communication. You should have secured communication, so that no user can bypass the security mechanism. Instead of HTTP, example is instead of HTTP, you can use HTTPS. This is secured. And use of separate NIC is network interface card for sensitive virtual machine. You have to use separate NIC, means you should not have a same network card for every virtual machine. You should have separate NIC for sensitive virtual machines, which is storing some sensitive information, confidential information. This is about the necessary precautions that or recommendations, guidelines that you have to use in order to um, make a virtualization strong. And then how virtualization is used on cloud computing. Cloud computing is all about virtualization. There is a strong bond between um, cloud computing and virtualization. When you have like this cloud, here you have all resources. This all resources, this is our cloud. They are accessed by users on pay and use basis. And then they all will have virtualization layer. So this physical machine, this is one physical machine. It is given as virtual machine 2, virtual machine 1, virtual machine 2, virtual machine 3. One physical machine is given as virtual machine to 3 different users. This is user 1, user 2, user 3. So virtualization is a very important feature of cloud computing. And because of virtualization in cloud, we are able to achieve shared services. Services are shared because of virtualization. And then you have elasticity. Elasticity means you can expand, scale up, and scale down the resources. You have service orientation. You can have a virtual machine for one particular service, and then you have metered usage. You start with the meter, means time countdown timer is um, switched on. You start using, and then it is off, and then you are billed. Like that is all possible because of this virtualization. So virtualization is the conclusion here is virtualization is the key enabler. Virtualization is key enabler. It is very important feature of cloud through which we are able to. So it is nothing but the foundation. Virtualization is the foundation of cloud computing. Okay, so virtualization is the foundation of cloud computing and key enabler. Virtualization for cloud. Okay, students, I hope everything is clear. If you have any doubt, please ask. Any doubts in today's class? Did you understand virtualization? All of you? Okay, then see you tomorrow. From tomorrow, we have to follow the timetable. I have shared the schedule. You will get a mail and also notification. So please join, and please on page number 136. Page number 136. MCQs are given. Try to mark the correct answers. Then, if time permits, we will discuss. So, bye, students, for today.